This is a problem like number 6 in section 7.2, in which we want to find the inverse Laplace transform, in this case of this s plus 1 squared divided by s cubed. Right now the only way that we know how to find an inverse Laplace transform is from the table on page 263, and this right here we don't see on that table. So what I'm going to do first is I'm going to expand this x plus 1 squared, and that's going to give me the inverse Laplace transform of s squared plus 2s plus 1 all over s cubed. And that's going to be the same as inverse Laplace transform. And now you see I have only one thing in the denominator, so I can divide each of the terms in the numerator by that s cubed. And so I get 1 over s plus 2 over s squared plus 1 over s cubed. And that is going to be then equal to the inverse Laplace of 1 over s plus 2 times the inverse Laplace transform of 1 over s squared plus the inverse Laplace transform of 1 over s cubed. So now we can use the table, and in particular I guess is B in 7.2.1, table 7.2.1, letter B, tells us that the inverse Laplace transform of 1 over s, I suppose this one is A, I suppose. This is 1. Now, here's where I use B. So if n plus 1 is 2, then n must be 1. And so I need an n factorial here, or 1 factorial. But 1 factorial equals 1, so I really do have it. And so this is 2 times t to the n, well, t to the 1, right? Now here I have s cubed, so it's supposed to be n plus 1, right? So n must be 2. And that tells me then that I need a 2 factorial here, so I'm going to write it just for a second. But obviously I've changed the problem unless I divide by it out here. And that's because the inverse Laplace and the Laplace work in the way that I can always pull out the constant. You see, if I pull out this 2 factorial out, then I've just multiplied by 1. I really haven't changed the problem. So then I can proceed now, and I have 1 over 2 factorial times t to the n, so t squared. Finally, this is 1 plus 2t plus 1 over 4 t squared. Sorry, 2 factorial is 2, not 4. 1 over 2 t squared.